learning today? Sarah asked a good question. Do we, or maybe it was Kelsey, do we need to learn long division? No, you don't need to learn it. Polynomial division using the generic rectangles will allow you to solve any of these problems. And it's a better method because it allows you to kind of check because you're visualizing it versus just seeing a bunch of numbers. Alright, so I am going to do this. I'm going to relate this actually to multiplication because that's how you think of using the box in the first place. It's a good place to start. So we'll start here. And I'll look at the box from this standpoint first. So let's say we have 3x squared minus x plus 2 times 2x minus 1. And once you get something bigger than two binomials, don't FOIL anymore. Use the box. It makes your life a lot easier. You're going to have 3 columns because the first 3 terms, and then 2 rows. 2x minus 1. I have to write this kind of small on here, but 3x squared minus x. Give myself a little bit more room. Plus 2 is go ahead and use the box, multiply, and combine your like terms. Alright, can we agree on the same answer here? Do you see any discrepancies or looks good? Make a mistake. What again is the relationship between the like terms? Diagonal, right? Which is really the key to the division. Let's move over to the division now. Alright, and some of you are having a hard time even on 59 figuring out how many columns to make. So I'm going to kind of give you a little advice on that when you're dealing with something with multiple terms. X to the 5th minus 3x cubed plus 2x minus 5 all divided by x plus 1. And here's where you start. X to the 5th minus, 3x cubed plus 2x minus 5 over x plus 1. So this number 5 tells you how many columns to build in your box. You're going to actually do 6 columns. The number, your degree plus 1. So whatever your highest degree is, 5 plus 1, that will be the number of columns. That will allow you to set up your box. Alright, so set up the box. Alright, so we know it's going to have 6 columns. And we know x plus 1 are going to go over here. And then the only other thing we know is the first term. We know the first term is going to be x to the 5th. Now some of you guys embarked on 62, which was great. But one of the other things that's different about this problem is it's missing some terms, right? It's missing the 4th power, and what else? What other term is it missing? The 2nd. So it's going to be helpful if we actually rewrite this with those placeholders. So x to the 5th plus 0x to the 4th, all the way down. Some of you guys are going to want to skip this step on the test because you're lazy. This is the truth of it. Will you get a different answer? I mean, if this has 6 columns, it's set up for 0x to the 4th and 0x squared. This is going to help you reference it. So these here, make sure you have them in. These are your placeholders. Take a little bit of time, rewrite those. Alright. You guys just want to try this on your own, or do you want me to kind of work through it with you? Alright, go for it. I'll give you guys 2 or 3 minutes. See how far you can get. Alright. Jalal, what goes up top? X times what's x to the 4th? Or x to the 5th? There you go. Alright, why don't you guys all tell me together what goes in the bottom box? Alright. And then this is where it starts getting a little tricky, a little different. X to the 4th plus what will give me 0x to the fourth? Negative x to the fourth. Those cancel. Which means at the top now I have minus x to the third. And the nice thing with this 1 down here, it's always going to be the same, right? So we get negative x to the third. Now we're going here, negative x, and I need to make 3. So how many more negatives do I need? 2, negative 2x to the third. I have a total of 3 now. Move to my next color here. And then what's going to go up top? Negative 2x squared. So on the bottom, same thing. It's just multiplied by 1. All right, we're here again. This is the kind of counterintuitive part. Negative 2x squared plus what will give you 0? Yeah, plus 2. They cancel, right? It's going to be the same thing. 2x squared and negative 2x squared will make 0. All right. 2x up top. 2x at the bottom. Yeah, probably. And now we're getting close to the end. 2x. Okay, so now I already have 2x, right? Yeah. What do I need to add to it then? 0x. And how do I make 0? Yeah, multiply by 0. Right? And that's 0. And then I'm almost to my last box, and I need to make negative 5, but can I make it? No, I'm done. And this is where we have a remainder. Okay, so the whole purpose in doing this, let's back up a sec. I'm recording here. 0 and negative 5 make negative 5. So we finish up the box, but negative 5, I mean, we can't go any farther. It doesn't work out. We're done. So instead of writing a remainder negative 5, we write it this way. Minus 5 all over x plus 1. In elementary school, you learned that this was just a remainder. The reason it's a remainder is because it's a fraction that's not evenly divisible. It's negative 5 over what is left, which is x plus 1. It doesn't fit perfect. Okay, so this would be your final answer. I don't want to see r equals negative 5 on the end of the test. It's negative 5 over whatever you're dividing it by, because that's really what it is. Yep. Question.